Welcome, traveler of the stars. You've arrived at the infinite scientist, where science dreams in the language of the cosmos. Tonight, we drift through the quiet corridors of the unseen world, where atoms breathe and silence becomes the shape of creation. If you find beauty in the mysteries of the universe, let your curiosity rest here. Subscribe and dream with us beneath the stars. Far beyond the reach of the senses, beyond the shimmer of dust that floats through morning light, there exists a silence so complete that even thought seems to dissolve within it. In that silence, the universe performs its smallest symphony. It is not made of sound nor of movement as we know it, but of trembling, infinitesimal, eternal trembling. The atoms that build everything you have ever touched are not still. They quiver gently, as though exhaling the memory of creation itself. Each vibration, each flicker of charge is a breath, the breath between atoms. In the beginning, before there were stars, there was this trembling. Space was not yet space. Time had not yet learned to flow, but quantum whispers stirred in the void. The universe inhaled possibility and exhaled existence. From that breath came hydrogen, the simplest of beings. One proton, one electron, dancing in an invisible orbit. It is strange to imagine that all the poetry of life, mountains, oceans, laughter, dreams, is woven from the choreography of these minute spheres of energy. The fabric of reality is stitched together not by solid things, but by patterns of motion too small to ever be truly seen. When you hold your hand before you now, you see a shape, a boundary. But at the atomic scale, that hand is a galaxy of emptiness. Between the nucleus of each atom and the electrons that swirl around it lies an ocean of nothingness. If the nucleus were the size of a grain of sand, the nearest electron would be several meters away. Everything that feels solid, the warmth of your skin, the firmness of stone, is merely the illusion of proximity, the gentle repulsion of fields that never truly touch. You are built not of matter, but of music, not of particles, but of relationships between them. Every breath you take is the continuation of that first cosmic sigh. In quantum chemistry, we learn that an atom is not a marble or a miniature planet. It is a cloud, a haze of probability that suggests where an electron might be found. The electron is both everywhere and nowhere, tracing invisible paths that blur into waves. We call these waves orbitals, and they are not circles, but shapes of possibility, petals, lobes, shimmering forms like frozen echoes. The mathematics that describe them are delicate, precise, almost sacred. Yet beneath the equations lies something profoundly human: uncertainty. Even in the smallest realm, the universe does not speak in absolutes. It whispers in maybes. When two atoms meet, they do not collide as stones do. They listen. Their clouds of probability intertwine, their electrons hum in shared resonance. A bond is born, invisible, yet strong enough to build mountains and carry oceans. This is chemistry at its most intimate, the meeting of possibilities. Hydrogen finds oxygen, and together they become water, the quiet architect of life. Carbon reaches out to carbon, forming chains that twist and fold into the very essence of you. Each molecule, each bond, is an act of trust. The universe learning to hold hands with itself. To imagine all of this is to feel both wonder and humility. The air that fills your lungs was once locked inside a star. The atoms that make up your bones were fused in the heart of ancient suns, scattered across the galaxy when those stars died. and gathered again into the fragile form you now inhabit. Every heartbeat is powered by reactions between oxygen and carbon, each a gentle rearrangement of quantum clouds. You are not separate from the cosmos. You are the cosmos, briefly aware of itself. And yet, within this vast connection lies a quiet mystery. Why should atoms combine at all? Why should the probabilities align in such a way that order blooms from chaos? The answer may rest in energy, the universe's eternal balancing act. Every atom seeks stability, a gentle stillness in which its energy is minimized. Bonds form because the universe, like us, desires calm. It trades tension for peace, chaos for harmony. The chemical bond is not violence, but resolution. A sigh after restlessness, a return to balance. If you could shrink yourself down to the scale of a single hydrogen atom, you would not find walls or edges. You would find waves, soft, overlapping, endless. You would drift through a luminous fog where boundaries lose their meaning. You would see how one atom becomes another, how the self dissolves into shared vibration. Perhaps that is the truest image of existence, a web of energy breathing quietly, exchanging itself with itself. There is no clear beginning or end, only continuity, only motion. Quantum chemistry, at its heart, is the study of this quiet breath. It is the story of how light becomes matter, how energy arranges itself into form. Every atom is a tiny compromise between chaos and structure. Every molecule is a memory of balance restored, and every living thing, you, me, these stars beyond the horizon, is a fleeting arrangement of those same particles vibrating softly in the endless night. When you close your eyes and feel your heartbeat, remember that it is not only blood you hear, but electrons shifting through the molecules of life. Each pulse is an orchestra of quantum events. Chemical reactions measured not in seconds, but in symphonies of motion. The rhythm of your breath mirrors the rhythm of the atoms that compose it. You inhale and exhale the same oxygen that once fueled the first fires of Earth, the same hydrogen that burned in the first stars. The breath between atoms is also your breath, and so the universe breathes through you, through every molecule, through the silent dance of probability and light. In this vastness, there is no true emptiness, only quiet connection. Every atom is listening to the next. Every vibration echoes another. The cosmos is not far away. It is inside you, speaking in the language of chemistry and calm. Somewhere in that stillness, the next story waits. A whisper carried on photons and possibility, waiting for light to learn how to speak. Light has always been the universe's storyteller. Long before there were eyes to see it or minds to interpret its dance, light carried the first whispers of existence through the newborn dark. It streamed across the emptiness, revealing the shape of everything that was to come. Yet for all its brilliance, light is not loud. It does not shout across the cosmos. It glides, it hums, it whispers. And within that whisper lies the quiet heart of quantum chemistry, where energy and matter begin their eternal conversation. Imagine a single photon, the smallest parcel of light. It has no rest, no weight, no solid form. It exists only in motion, and in that motion it becomes the messenger of all creation. Every color you have ever seen, every warmth you have ever felt on your skin, every chemical reaction that gives life its spark, all of it begins with this weightless traveler. When light meets matter, it does not collide. It caresses, it persuades, it changes the rhythm of electrons as if teaching them a new melody. In the quantum world, light and matter are not separate actors. They are partners in a dance that never ends. When an atom absorbs light, its electrons leap to higher states of energy, not as tiny particles climbing ladders, but as waves expanding into new patterns. This act is what scientists call excitation, the awakening of an atom. It lasts only for the briefest moment before the electron relaxes, falling back into its previous orbit and releasing light once again. To our eyes, that release becomes color. To the atom, it is simply a breath, an inhale and exhale of energy. If you could watch this happen not through equations but through feeling, it would look like a pulse of warmth rippling through space, a heartbeat in slow motion. Every flicker of a candle, every glimmer on the surface of water is made of countless atoms taking in light and giving it back, whispering the same story over and over. I have been changed, and in changing, I shine. Light is more than brightness. It is information, motion, and the architecture of chemistry itself. When a photon strikes a molecule, it can rearrange bonds, ignite reactions, or break them apart. This is how plants learn to eat sunlight. In the green depths of their leaves, photons are captured and converted into the language of life. The chlorophyll molecule absorbs light and channels its energy through a sequence of reactions that create sugar, a quiet miracle that feeds not just the plant, but the entire living world. The same quantum principles that guide an atom's electrons also shape the forest's breath and the ocean's calm. But even this miracle begins with uncertainty. A photon does not take one path through space. It takes all paths simultaneously. Until it meets an atom, it is everywhere it could possibly be. When it is absorbed, that infinite possibility collapses into a single moment of contact, a quantum whisper becoming real. It is a reminder that light, though it seems constant and clear, lives in a world of uncertainty too. What we see as brightness is only the shadow of probabilities finding harmony. In quantum chemistry, this harmony is described through the strange duality of light, sometimes a wave, sometimes a particle, always both. It depends on how we listen. When we study light as a wave, it shows us interference, rhythm, and spread, like ripples on a pond. When we look for particles, we find photons arriving in discrete quanta, one after another, as if knocking gently on the door of matter. These are not contradictions, but different perspectives of the same mystery. Light, like truth, changes depending on how we observe it. Through this relationship between light and atoms, the universe paints its invisible landscapes. When a molecule absorbs or emits certain wavelengths of light, it leaves a signature, a pattern of color that reveals its identity. Astronomers read these spectral lines to understand what stars are made of, even from billions of miles away. Every element sings its own quantum song, and light carries those songs through time and distance. When we gaze at the stars, we are not just seeing their light, but we are hearing their chemistry translated into color. Perhaps that is why light feels sacred. It connects the smallest scale of quantum vibration to the largest sweep of galaxies. It binds the microscopic to the infinite. Without it, atoms would remain isolated, blind to one another's existence. With it, the universe becomes visible to itself. Every sunrise is an ancient dialogue renewed. Photons born in the heart of the sun, crossing the void to brush against molecules in the air, scattering into gold and crimson, whispering, "I have come far to touch you." There is a tenderness in that thought. The light that reaches your eyes right now has traveled across unimaginable distances. Some of it began its journey before humanity ever existed. Some of it is ancient starlight, billions of years old, that has wandered through dust and darkness to arrive precisely where you are sitting. And when it meets the molecules in your retina, it transforms again, its energy converted into electrical impulses, patterns of perception, images that your mind interprets as beauty. You are not merely seeing light, you are becoming light, just for an instant. In this way, the boundary between physics and feeling blurs. Quantum chemistry shows us that energy does not vanish, it only changes form. The warmth of sunlight on your skin is the same energy that once lived in the core of a star. The glow of a candle in a quiet room is the echo of chemical bonds rearranging themselves, releasing photons as a sigh of release. Light is the gentle storyteller of change, carrying news from one form of existence to another. And when night falls and the stars emerge one by one, you can almost feel their whispers crossing the darkness. Each photon that reaches you carries a memory of the atom that birthed it, a pulse of energy transformed across unimaginable space. The same laws that guide their journey govern every reaction within you. Your heartbeat, your breath, your thoughts, all of them powered by the chemistry of light captured long ago. So when you close your eyes, you are not stepping away from the light. You are stepping into its echo, the quiet hum of energy that fills all things. Even in darkness, the whisper continues, soft, patient, endless. For light is not only what we see, it is what allows us to be. It is the universe's way of saying, I am here and I am still breathing. And somewhere beyond that whisper, deeper in the quantum hush, the waves of energy begin to dance. Not just light, but matter itself, rippling in invisible patterns that weave the next secret of existence. In the stillness between seconds, where time seems to hover rather than flow, the universe moves in ways the human eye will never see. Beneath every object, every thought, every heartbeat, a hidden choreography unfolds. The dance of invisible waves. It is not a dance of limbs or sound, but of energy folding into itself, forming the rhythm that builds reality. Nothing in existence is ever truly still. Everything hums with a vibration too delicate for touch, too intricate for sight. The entire cosmos sways to this inaudible music, a waltz written in the language of quantum mechanics. Once, scientists believed the world was made of small, solid marbles, indivisible particles that clumped together to form the matter around us. But as our eyes sharpened through microscopes and our minds deepened with mathematics, we began to see differently. What appeared solid dissolved into patterns, and what we called particles revealed themselves to be waves, shimmering ripples of probability spreading through space. Each electron, each proton, each atom was no longer a fixed dot, but a possibility, oscillating between being and becoming. This revelation was not just scientific, it was poetic, for it showed us that existence itself is fluid and certainty is a fragile illusion. To know where something is means we cannot know how it moves. To know how it moves means we cannot know exactly where it is. This is the principle of uncertainty, not a failure of knowledge, but a reflection of the universe's subtle truth. The quantum world does not give us answers in sharp lines. It speaks in gradients, in blurred edges where matter and energy are one and the same. If you could shrink yourself to the size of an electron, the world would no longer look like a landscape of objects. You would see fields. Vast, glowing seas of probability that shimmer with constant motion. Each particle would appear as a soft pulse in that sea, rising and falling like the crest of a wave. You would see yourself moving not through space, but through patterns of energy, each wave interacting with another in endless superposition. The atom's interior would not be a miniature solar system, but a vibrating song, harmonies of electrons weaving their frequencies into elegant shapes of light and motion. Wave-particle duality, the cornerstone of quantum thought, tells us that all matter behaves as both. An electron can act like a particle, leaving a dot on a detector screen, or like a wave, spreading and interfering with itself when no one is watching. Its identity depends on how we ask the question, how we observe it. The act of observation, of looking, changes the outcome. Reality itself seems to respond to consciousness, as though awareness and existence are threads of the same tapestry. This dance of invisible waves extends far beyond atoms. It defines every aspect of chemistry, the bonding of molecules, the flow of energy, the shimmer of colors. When two waves meet, they can strengthen or cancel each other, just as two ripples on a pond combine to form patterns of stillness and storm. The electrons that circle nuclei do not orbit like planets. They form standing waves, stable vibrations that define where they are most likely to be. These standing waves become the orbitals of atoms, the silent architecture of all chemistry. It is here, in these wave patterns, that matter learns to hold shape. The atoms that form your body, your breath, your thoughts, each one vibrates in intricate resonance. Bonds are not wires holding atoms together, but harmonies, alignments of frequencies where one atom's wave complements another's. When the vibrations align perfectly, stability is born. When they misalign, energy releases, light escapes, reactions spark into being. Chemistry is the choreography of these resonances, and quantum mechanics writes the score. Consider for a moment the double-slit experiment. It gives one of the most haunting glimpses into the quantum dance. When light or electrons are sent through two narrow slits, they do not simply form two lines on a screen as particles would. Instead, they create an interference pattern, a sequence of bright and dark fringes, as if each particle passed through both slits simultaneously and interfered with itself. Only when we watch closely, when we measure which slit it goes through, does the pattern collapse into two ordinary lines. The act of observation seems to quiet the dance, forcing the universe to choose a form. When we look away, the music resumes, everything possible happening all at once. This experiment whispers something profound about reality, that it may be fundamentally relational. Things do not exist in isolation, they exist in connection, in the interference of their waves. You and I, every star and every grain of dust are parts of the same cosmic interference pattern, each shaping the other by our very presence. Perhaps this is why silence feels alive, why solitude hums, because even in emptiness the waves are dancing. At the scale of life, this dance becomes invisible but never stops. Within your body, electrons leap between energy levels, molecules vibrate in countless configurations, bonds stretch and relax in response to heat, pressure, or thought. Every breath is an orchestra of quantum motion. The warmth you feel from another's touch is the vibration of shared energy, waves mingling for a fleeting moment before returning to their own rhythm. The glow of a fire, the sparkle of a jewel, the beating of your heart, all are waves, exchanging information, resonating through the quiet fabric of the universe. There is something deeply comforting in knowing that we too are made of waves. It means that we are never fully separate, never truly alone. Our energies overlap with those of others. Our emotions ripple outward like concentric circles in a pond. Every thought you have, every sound you make, alters the field around you in ways too subtle to measure yet too real to deny. You are part of the universe's great vibration, a fleeting note in an endless song that began before time and will continue long after. When you stand by the ocean and listen to its rhythm, you are listening to yourself at a grander scale. The waves that rise and fall before you follow the same mathematics as the electrons that shape your being. They are both governed by interference, resonance, and flow. The difference is only in size, not in essence. The sea outside and the sea within are the same story written in different languages, and so the universe continues its silent dance. Atoms within molecules, molecules within cells, cells within living worlds. Each step of the rhythm builds upon the last, spiraling outward into galaxies and inward into thought. The waves that compose you will one day drift elsewhere, merge into other forms, sing new harmonies, but the music will never end. It is the same song that began in the breath between atoms, carried forward by light, and now unfolding in the endless choreography of being. Tomorrow, the dance will deepen. The electrons will reveal their hidden gardens, where energy blooms in quiet symmetry, and the quantum pulse of life continues to unfold. Deep within every atom, hidden beyond the edge of sight, there lies a garden unlike any other. It has no soil, no air, no boundary. It is woven from pure possibility, a place where light and energy bloom in invisible shapes. This is the realm of the electron, the quiet gardener of matter, tending to the invisible architecture of the universe. Without it, nothing would hold form. With it, everything, from the shimmer of dew to the pulse of a heartbeat, finds its pattern. To imagine this garden, one must first let go of the familiar. The electron is not a speck, orbiting a nucleus like a planet around a star. It is a wave of probability, a mist of potential that wraps itself around the heart of the atom. At any given moment, it could be anywhere within its allowed region or everywhere at once. What we call an orbital is not a path, but a map of where the electron might exist. A sculpted cloud of energy, drawn not by hand, but by the mathematics of nature's most elegant logic. Each orbital has its own character, its own geometry. Some are spherical, smooth and simple, like quiet ponds of potential. Others stretch into lobes and petals, intricate and strange, shaped by the balance between attraction and motion. These are not arbitrary designs. They are the fingerprints of quantum mechanics. They describe how energy distributes itself when bound by the electric pull of a nucleus. In this sense, every atom is a gallery of invisible art, its electrons forming patterns that hold the memory of creation itself. The garden of electrons is not static. It breathes. It pulses with transitions, jumps from one energy level to another, moments when electrons absorb or release light. When an electron rises to a higher state, it is like a seed reaching toward the sun, fueled by a photon's touch. When it falls back, it releases that light again, a silent blossom of radiance. This process happens in every flicker of flame, every glint of metal, every star that burns across the void. The electron's secret garden is the stage upon which all brightness is born. Quantum chemistry gives us tools to describe this secret life: Schrödinger's equation, wave functions, and probability densities. But behind those symbols lies a deeper truth. The electron is not a prisoner of certainty. It exists as a superposition of possibilities, exploring all of them until it is observed. Only then does it choose one, collapsing its infinite potential into a single reality. This act, this quiet decision, is repeated countless times every moment, everywhere. The world we see is built from the sum of those choices. If you were to peer into this garden at the right scale, you would not find movement in the way you understand it. You would see interference, ripples of wave functions overlapping, forming regions of calm and chaos. The electron is not moving in a circle. It is standing as a vibration, a resonance shaped by the invisible tug of the nucleus. Each atom's garden has its own song. Hydrogen hums a single tone, while larger atoms sing chords of many frequencies. And when atoms join to form molecules, their songs combine, harmonizing into the chemistry of life. In this way, the electron is both artist and composer. It sculpts the shape of matter and scores the melody of reactions. When two atoms approach, their gardens merge, their electron clouds intertwining. If the overlap is harmonious, a bond forms. A delicate handshake of shared probability. The electrons are no longer bound to one atom or the other. They belong to both, moving in rhythms that connect the two hearts of matter. The universe holds itself together through these shared dances, not through force but through resonance. The same principle that binds a molecule together also fuels the stars. In the heart of a star, electrons are stripped from atoms and flung into seas of plasma, their gardens dissolved into light. Yet even there they shape the process of fusion, guiding protons to merge and form heavier elements. When those stars die, they scatter the fruits of their burning, oxygen, carbon, iron, across the cosmos. The electrons return to calmer forms, reforming their gardens within new atoms, new worlds, and eventually within you. The breath you take now is filled with electrons that once danced in the heart of suns. There is something almost spiritual in that thought. These tiny particles, invisible and restless, are the architects of all order, the keepers of balance. They decide whether a crystal shines or dulls, whether a molecule conducts or insulates, whether life can emerge or fade. Yet, they do all of this without intention, guided only by the quiet laws of probability. They remind us that beauty does not require purpose, that harmony can arise from chaos if the rhythm is true enough. Philosophers once spoke of a vital force, a spark that animated matter into life. Modern science no longer uses that term, yet when we look into the electron's garden, we find something that feels very much like that spark. For life, at its core, is the result of electrons moving between states, rearranging bonds, exchanging energy in subtle choreography. Every heartbeat is an electron's decision, every thought a chemical shift, every moment of love or loss a cascade of quantum transitions that keep you alive. The electron's garden is not separate from you, it is you. When you touch another hand, electrons repel before contact. You never truly touch. Instead, your electron clouds meet, pushing gently against one another, creating the illusion of pressure. When you see someone's face, photons, released by electrons, travel from them to you, carrying their image. Every connection you feel, every sensation, is mediated by these tiny gardeners. They tend the boundaries of matter and light, keeping the world from collapsing into chaos. And yet, there is no real boundary at all. The electrons that surround you are not confined to your body. They exist as part of a continuum, exchanging with the world in every breath, every meal, every passing moment. The garden is not yours alone. It is shared. You inhale oxygen and its electrons mingle with yours. You exhale carbon and those electrons drift into the air, into trees, into oceans, into someone else's future breath. The dance never ends. It only changes shape. If you close your eyes and imagine the world without sight or sound, you might sense this hidden movement. The hum beneath stillness, the shimmer beneath skin. That is the electron's garden, alive and eternal. It does not speak, but it sings in frequencies older than time. It does not think, but it remembers every spark of creation. In its quiet order, it carries the story of everything that ever was or will be. And somewhere beyond this garden, the waves begin to fold into patterns more intricate still. Patterns that decide how the universe dreams of possibility, where uncertainty itself becomes the seed of creation. Somewhere between what is real and what is possible, the universe dreams, not in words or pictures, but in probabilities. Soft, shimmering clouds of maybe. Every atom, every particle, every choice in the vastness of existence is born in this uncertain space where reality has not yet decided what to become. To understand the quantum world is to step gently into this dream, to see not a world of solid shapes, but of endless possibilities folded together, waiting to unfold. In the macroscopic world, the one we touch, see and trust, everything seems clear. A stone falls, a wave breaks, a flame flickers, and their paths appear certain. But beneath that clarity, the smallest components of the universe follow no such certainty. They move according to probabilities, not certainties. They do not travel from one place to another along a defined road. Instead, they exist as a cloud of potential locations, a fog of overlapping outcomes. Only when we look, only when we measure, does the fog collapse into a single form. Before that, the universe is undecided, like a thought that has not yet been spoken. This idea, strange and unsettling at first, lies at the heart of quantum chemistry. It tells us that reality is not a solid story written in ink, but a living poem written in possibilities. Every electron in an atom exists not at one point but across many, its presence spread like a melody across space. Each of these possibilities interferes with the others, creating patterns of probability, the very shapes we call orbitals. These waves of maybe define how atoms connect, how molecules form, how reactions unfold. Chemistry, at its core, is the art of probability learning to take shape. To visualize this, imagine a single electron as a drifting mist. The denser parts of the mist mark where it is most likely to be found, and the lighter parts where it is less likely. But the electron itself does not exist in the mist. It is the mist. It is not one thing, but all its possible versions woven together. When two atoms approach, their mists overlap, and the probabilities intertwine. Some possibilities strengthen each other, forming bonds. Others cancel, forming spaces where the electron cannot exist. Out of this dance of reinforcement and cancellation, the molecular world emerges, from hydrogen to water to life itself. Erwin Schrödinger, one of the architects of quantum mechanics, described this unfolding with his now famous equation, a mathematical lullaby that predicts how probability waves evolve. His equation does not tell us where a particle is. It tells us how its potential changes over time. It shows that nature does not move from one state to another in a straight line, but flows like water through channels of possibility. It was this realization that transformed our understanding of chemistry. Atoms no longer seemed like mechanical gears in a clockwork universe. They became living patterns of energy, each capable of countless configurations. From that realization came one of the most haunting concepts in all of science: superposition. A quantum system, a particle, an atom, even a molecule can exist in multiple states at once. It is as if reality itself can hum two notes simultaneously, and only when listened to does it settle on one. This principle lies at the root of every chemical reaction. When a molecule reacts, it does not follow a single path. It explores all possible paths at once, and the final result is the sum of all those probabilities. Every transformation, every release or absorption of energy is a choice made by the universe through this quantum dreaming. Consider, for example, the moment when sunlight strikes a leaf. A photon, a quantum of light, encounters a molecule of chlorophyll. The photon's energy lifts an electron to a higher level. But in that moment, the electron does not simply jump. It exists in a superposition of being both excited and not excited until the rest of the system interacts with it, forcing a decision. This uncertainty, this in-between, is the essence of life's machinery. Even photosynthesis depends on probabilities folding and unfolding with perfect precision. At first glance, this might seem chaotic, a world without stability, ruled by chance. But within this uncertainty lies exquisite order. Probability does not mean randomness. It means flexibility. The quantum world is not disorderly but deeply harmonious, like 1,000 voices singing different notes that somehow resolve into a perfect chord. Each outcome that becomes real is one among many that could have been. And though we see only the chosen note, the harmony of all the others still shapes it. This principle does not stop at atoms. It ripples through the fabric of existence. Every chemical reaction in your body, every spark of thought, every beat of your heart unfolds as a cascade of probabilities collapsing into reality. The heat that rises from your skin is the echo of electrons releasing energy they once held in superposition. The color of the sky, the smell of rain, the taste of salt, all are born from probabilities resolving into presence. You are quite literally made of decisions the universe has quietly made about itself, and yet there remains a mystery. Why does observation, the act of measurement, seem to make these decisions happen? Physicists have debated this for a century. Some say the observer forces the universe to choose, others that the act of measurement is simply another interaction within the web of possibilities. But there is poetry in the idea that awareness itself participates in creation, that in watching, we help the world decide what to be. Perhaps consciousness is the universe's way of gazing upon its own dreams, folding them into being. Philosophically, this vision changes how we might see ourselves. We are not passengers drifting through a predetermined reality. We are participants in the unfolding of probability, part of the dream itself. Every thought, every action sends ripples through the quantum fabric, changing the balance of what might be. The boundaries between physics and existence blur until they are indistinguishable. When you look at the stars, the light that reaches your eyes carries the memory of probabilities collapsed long ago. Each photon was once uncertain, wandering through paths uncountable until it finally touched your gaze and became real. The cosmos does not simply exist. It becomes, over and over, through endless acts of becoming, and as you breathe, the electrons within your body continue their quiet superpositions, occupying many states, exploring countless options, then resolving into this singular moment you call now. You are not fixed. You are a cloud of possibility momentarily shaped into form. When you dream, perhaps it is not only your mind that drifts through imagined worlds, but your very atoms, remembering the language of probability. For in that dream, as in the quantum realm, everything is possible. The boundaries dissolve and reality waits to be chosen. In the next quiet unfolding, these probabilities will weave into the music of matter itself. The resonance that allows the universe to sing beneath its surface, turning chance into harmony, energy into form, and silence into the pulse of creation. If you listen closely enough, not with your ears, but with the stillness inside you, you might sense a vibration that does not come from sound. It hums beneath all things, beneath the wood of your desk, the weight of your hand, the quiet of the night. This hum is not carried by air or string. It is the song of matter itself. Every atom, every molecule, every piece of existence vibrates with its own rhythm, tuned to the energy of being. The universe, at its most intimate scale, is not silent. It is music made of motion. The ancients once spoke of the music of the sphere, the idea that celestial bodies moved in perfect harmony, producing tones beyond human hearing. They were not entirely wrong. The truth, revealed by quantum chemistry, is that the harmony is not out there among the stars, but deep within the fabric of everything that is. Matter sings, and we are made of its notes. The electrons dance, the spin of nuclei, the trembling of bonds. All these form the orchestra of existence. Each molecule resonates, each vibration contributes to the melody of the world. To understand this music, we must remember that every atom is bound by energy, and that energy moves. When two atoms bond, they do not hold still. They oscillate, pulled together by attraction and pushed apart by repulsion. These oscillations create vibrations, not of sound but of frequency, measured not in hertz we can hear, but in energies that define the warmth of matter itself. To the chemist, this is called vibrational motion. To the poet, it is the heartbeat of the cosmos. Each bond has its own tone. The bond in water vibrates differently from the bond in carbon dioxide or methane. These frequencies can be measured, seen even, by the way molecules interact with light. When infrared light passes through a gas, some wavelengths are absorbed, not because of color, but because the light's energy matches the molecule's vibration. In that absorption, the molecule takes a photon and hums a little louder. This is how scientists can identify substances from afar, by reading the score of their vibrational music written in light. Imagine, for a moment, a world viewed not through eyes but through this hidden hearing. You would see air molecules trembling in invisible symphonies, the warmth of your breath glowing like a melody. You would see glass vibrating faintly at its resonant frequencies, metals singing with the vibrations of their lattices. Even silence would not be empty, it would shimmer with motion. The universe never stops playing. In the quantum realm, these vibrations are quantized, meaning they can only take on certain discrete notes, certain allowed energies. A molecule cannot vibrate at any arbitrary frequency. It can only sing in harmonies permitted by its structure. These quantized vibrations form the foundation of spectroscopy, the science that listens to the whispers of molecules. Each material, each compound has a unique vibrational fingerprint, a melody so specific that no two are exactly alike. It is as though the universe composed a different theme for every object it ever made. These quantized vibrations are also the origin of heat. When you feel warmth on your skin, what you are truly feeling are the countless vibrations of molecules colliding and resonating. Temperature is the measure of this movement and a measure of how intensely the orchestra plays. When matter is cooled toward absolute zero, the music softens. The vibrations slow, growing quieter and quieter until they almost stop. Yet even then, a faint note remains. The 0-point energy, the smallest possible vibration allowed by quantum law. It is proof that the universe can never be completely silent, for even emptiness must hum with life. This music does not merely decorate existence, it sustains it. Chemical reactions occur because of vibration, because bonds stretch and bend until they find new configurations. When two molecules collide, their vibrations determine whether energy will flow, whether new bonds will form, or old ones will break. The success of chemistry depends not on force, but on resonance. When frequencies align, when energies match, the reaction proceeds like harmony resolving into a chord. When they do not, the notes clash and nothing happens. In this sense, every transformation in the universe, from the burning of a star to the folding of a protein, is a musical event. If we could translate these frequencies into sound, the world would become an unending symphony. Hydrogen would hum softly, oxygen would pulse like a cello, carbon would strum in complex overtones. The molecules of your body would form a chord too rich for any ear to hear. A harmony built from billions of subtle vibrations interwoven. Perhaps this is why music affects us so deeply. It resonates with what we already are. When a melody moves you, it is not only your mind that responds, but your molecules. Each atom echoing the frequencies that sustain it. The music beneath matter calls to the music within. Even the human voice is a manifestation of this principle. When you speak or sing, air molecules vibrate, carrying waves that mirror the microscopic vibrations in your body. The sound you create is a magnified version of what happens constantly at smaller scales. You are in essence an instrument built by the universe to sing itself back into awareness. Every word, every song is an echo of the atomic rhythms that gave rise to you. In the stillness of space, stars too vibrate. Their outer layers pulse with standing waves, enormous resonances that reveal their internal structures. Astronomers listen to these oscillations through light, turning them into sound we can almost hear. A star's tone can tell us its age, its size, its composition. Across the vastness, the stars sing to one another in the language of vibration, and through them, the cosmos keeps time. There is something deeply reassuring about this truth, for it means that stillness is never empty. Even in the quietest corner of the universe, movement continues. Matter hums softly, unseen yet unceasing. And we, beings of vibration, are tuned to that frequency whether we realize it or not. The rhythm that beats in your chest is not separate from the rhythm that ripples through a distant nebula. Both arise from the same law, the same cosmic harmony that began with the universe's first note, a burst of energy expanding into space and time. So the next time you sit in silence, know that you are not truly alone in it. Within you, the atoms of your body are vibrating in elegant synchrony, molecules exchanging their energy in delicate patterns. Around you, the world trembles in unending resonance. All of it, every hum, every motion, every whisper of light, is part of a single composition. The universe does not merely exist, it sings. It has always sung, and as the vibrations deepen, as harmony meets attraction, the invisible bonds begin to form. The quiet linkages that hold the music together, binding the universe in ways we cannot see but can always feel. Between two atoms, there is a space so small it seems impossible that anything could exist within it. And yet everything begins there. In that invisible distance, attraction whispers, electrons wander, and energy reshapes itself into connection. It is here, in the silence between particles, that the universe learns to hold itself together. Every molecule, every breath, every cell in your body depends on this quiet act of joining. The bond that cannot be seen is the bond that makes existence possible. When we speak of bonding in chemistry, we often imagine something mechanical, atoms locking together like puzzle pieces, forming a solid chain of matter. But at the quantum level, it is not shape or pressure that brings them close. It is the subtle balance between energy and probability, between wanting to exist apart and yearning to exist as one. Two hydrogen atoms drifting through space will only join when their separate electrons find harmony, when their overlapping clouds of possibilities sing the same note. In that alignment, energy is released, and the atoms become something new, a molecule. H2, a single moment of cosmic cooperation, multiplied trillions of times, gives birth to water, air, life. To understand this invisible bond, imagine the electron not as a particle, but as a wave, soft, spread, uncertain. Around each atom, this wave forms an orbital, a region of probability. When two atoms approach, their orbitals merge, and the waves interfere. Some parts amplify each other, building stronger regions where electrons are likely to be found. Others cancel out, leaving silent voids between. This interference pattern is the true bond, not a line between atoms but a shared rhythm of probability. The electrons no longer belong to one atom or the other. They belong to both. In this way, quantum mechanics reveals that bonding is not a matter of possession, but of sharing. The universe connects not by ownership, but by overlap. The beauty of chemistry lies in that generosity, electrons weaving themselves into patterns that hold everything together without ever truly settling in one place. Bonds form not because matter is rigid, but because it is flexible, willing to share its identity for the sake of stability. There are many kinds of these bonds, each with its own tone in the cosmic harmony. The simplest, the covalent bond, is born from shared electrons, a mutual agreement between atoms to hold each other in balance. It is the gentlest and most intimate of connections, where energy is not forced but negotiated. Then there is the ionic bond, a more dramatic union born of difference. One atom surrenders an electron, the other receives it, and their opposite charges pull them close. It is attraction through contrast, a dance of opposites that forms salts, crystals, and minerals. There are metallic bonds too, where electrons drift freely among many atoms, creating structures that can conduct electricity and reflect light. Each bond in its own way is a story of energy seeking rest, of the universe finding new ways to organize itself. In the early days of chemistry, before quantum theory revealed the hidden mechanisms, bonds were thought of as mere forces, mysterious attractions acting at a distance. But the quantum world showed us the truth. Bonding is not a force in the ordinary sense. It is the result of the wave nature of matter. It happens because electrons prefer to exist in the lowest possible energy state. And the lowest energy often lies not in solitude, but in connection. When two atoms join, they share their electrons in such a way that both become more stable, their combined energy lower than their separate energies. The bond, then, is not a string or glue, but a reduction in restlessness. It is the calm that arises when the universe finds harmony within itself. Consider the molecule of water. Simple, ordinary, yet miraculous. Two hydrogen atoms bond with one oxygen atom, their shared electrons creating a bent shape that gives water its remarkable properties. Because of the uneven sharing of electrons, one side of the molecule becomes slightly negative, the other slightly positive. These tiny charges reach out, allowing water molecules to bond weakly with each other through hydrogen bonds. Ephemeral, fleeting, yet essential. It is because of these invisible connections that water can dissolve, flow, and hold life. Every drop you've ever touched is a tapestry woven from billions of bonds that flicker and fade in an instant, yet collectively endure. And in that endurance, there is poetry. For what is love, what is friendship, if not a kind of molecular echo? We too are drawn together by unseen forces, by the sharing of energy, by the lowering of loneliness. Just as atoms bond to find stability, so do we seek connection to find meaning. The chemistry of the cosmos mirrors the chemistry of the heart. In both, unity is born not from sameness, but from resonance, from the courage to overlap without losing oneself. When a bond breaks, energy is released or absorbed depending on the balance of forces. In that release lies transformation. Burning wood, digesting food, breathing oxygen, all are processes of bonds breaking and forming anew. Energy flows through these transitions like rhythm through music, never created, never destroyed, only changing its form. Life is nothing more than the choreography of these invisible exchanges, the endless forming and dissolving of bonds. At a deeper level, even within atoms, the same principle holds. Protons and neutrons inside the nucleus are held together by the strong nuclear force, the most powerful and mysterious bond of all. It acts only across unimaginably small distances, yet it holds the matter of the universe together. Without it, atoms would scatter like dust. Even the stars owe their light to the balance between bonding and breaking. Fusion joins nuclei, releasing the energy that illuminates space. The bond unseen is the heartbeat of the cosmos. Perhaps this is why stillness is never truly still. Every solid object you touch, in a stone, a table, your own skin, is alive with invisible motion, with bonds vibrating and stretching, holding the world in delicate tension. The solidity you feel is an illusion born from countless invisible relationships. The universe is not built of things, but of connections. Every moment, every breath is the sum of unseen partnerships playing out beneath awareness. And if you close your eyes and imagine the space between atoms, that empty field alive with probability, you might begin to sense how everything that exists is bound by the same gentle truth, that nothing stands alone. The stars that burn, the cells that divide, the air that fills your lungs, all are held together by invisible threads of energy and trust. The bond cannot be seen, but it can be felt in every pulse of existence. It is the universe's quiet promise to itself, to hold, to share, to stay. And when those bonds vibrate in unison, when molecules move together as one, they carry the memory of motion, the continuation of connection. Somewhere in the quiet between seconds, every molecule remembers. It remembers the way it once drifted as dust, the way it collided, spun, and bound itself into something more. The story of matter is not a straight line. It is a rhythm, an echo of countless movements replaying across time. Even now, within your breath, the molecules of oxygen and carbon dioxide carry the memory of ancient oceans, of volcanic skies, of stars that burned long before the Earth was born. They move as they always have, dancing in patterns written by the earliest vibrations of the universe. At the molecular level, motion is never truly random. Though it may seem chaotic, countless particles colliding, twisting, rebounding, there is order within the frenzy. Every molecule moves according to energy, to the invisible currency that drives the cosmos. This motion is what gives temperature its meaning. To say that something is warm is to say that its molecules are moving swiftly, vibrating and tumbling with intensity. To say that something is cold is to say that motion has slowed, that the molecules have curled inward into stillness. Even in solid stone, where everything feels unmoving, the atoms still tremble faintly, bound but never at rest. Stillness, in truth, is only a slower kind of dance. Motion defines chemistry because it creates possibility. A molecule is not a static sculpture. It is a living rhythm, its atoms connected by bonds that bend and stretch, rotate and twist. Every chemical reaction begins with movement, with molecules colliding in just the right orientation, at just the right moment, carrying just enough energy to overcome the invisible barrier between old bonds and new. These fleeting moments, called transition states, last less than the blink of an electron, yet they decide everything that follows. The world as we know it is the accumulation of successful collisions, tiny partnerships formed in the blur of molecular motion. In the early 20th century, scientists began to see that this motion was not merely mechanical, it was quantum. At small scales, the boundaries between movement and energy blur. Molecules do not slide along continuous paths. They leap between discrete energy levels, exchanging quanta-like dances, changing steps to a new tempo. Each vibrational mode, each rotation, is quantized, allowed only specific patterns of motion. These patterns are what make molecules identifiable, each one carrying its own signature rhythm, its unique memory of motion written in the language of energy. Infrared spectroscopy lets us listen to these memories. When light passes through a substance, certain wavelengths are absorbed, causing molecules to vibrate more intensely. These absorptions create a fingerprint of frequencies, a pattern of lines that tells scientists not only what molecules are present, but how they move. Each molecule sings a slightly different song. Water hums with a deep, resonant tone. Carbon dioxide resonates in a symmetrical stretch. Methane pulses in a complex chord of rotations and bends. These molecular songs are ancient, unchanged since the dawn of time, echoing the same patterns that first shaped the universe. But motion is not only vibration. Molecules can also rotate freely in gases, spin in liquids, and oscillate in solids. As they do, they exchange energy with their surroundings. In this ceaseless exchange, the universe balances itself. Energy flows from motion to stillness, from heat to cool, until equilibrium is found. Yet even equilibrium is not true silence. It is a state of motion so balanced that it feels like rest. The molecules never stop moving. They are always whispering, always remembering. Think of the air you breathe. In one inhalation, you draw in roughly 10 sextillion molecules, 10 followed by 21 zeros. They enter your lungs, bounce against membranes, dissolve into blood, and flow into your cells. Many of those molecules have been here before. exhaled by trees, carried by oceans, released from volcanic vents, breathed by animals long gone. Some of the nitrogen in your body once drifted in the belly of a dying star. Some of the oxygen once shimmered in the icy tail of a comet. Every breath you take is an inheritance of ancient motion, the cosmos cycling through you and back again. Even within your body, molecular motion is the language of life. Proteins fold by exploring countless configurations until they find the one of lowest energy, a process guided by vibrations and collisions too small to see but too precise to be random. Enzymes catalyze reactions by choreographing this motion, aligning atoms so that bonds break and form as if guided by invisible hands. In your muscles, chemical energy stored in molecules of ATP is released through molecular motion, transformed into the physical movement of your limbs. Every heartbeat, every blink, every thought is the orchestration of molecules remembering how to move. And though it may seem mechanical, there is something deeply graceful in this dance. The rhythm of molecules mirrors the rhythm of existence itself. The rise and fall of energy, the balance between motion and rest. Just as a wave on the ocean surface reflects the deeper currents below, the motions of molecules reflect the deeper energy fields that shape reality. Even time as we perceive it is entwined with motion. Without movement, there is no change. Without change, there is no time. The ticking of molecules, their vibrations and rotations, is the heartbeat by which the universe keeps time. When you hold a glass of water and watch it ripple, remember that those ripples are the visible echo of motions happening on scales you cannot see. Each droplet contains quadrillions of molecules moving in unison, exchanging energy, resonating in the same timeless rhythm that once pulsed through interstellar clouds. The water's shimmer is not just reflection, it is memory. The molecules remember being vapor and ice, storm and sea. They remember the collisions that shaped them, the energy that carried them across light years, the slow cooling that turned chaos into calm. The memory of motion never fades. It only changes form. In the stillness of a frozen lake, that memory lingers. The molecules are locked in crystalline patterns, their motion slowed almost to silence. Yet even there, beneath the ice, they vibrate faintly, whispering the same rhythm that pervades all matter. When spring returns and warmth stirs the molecules again, they remember what to do. They move, flow, and live once more. Motion, in the end, is not something that happens to molecules. It is what they are. Matter is motion bound temporarily into structure by the delicate balance of energy. Everything that exists is movement slowed just enough to hold shape. We too are motions paused in a pattern, for a moment between birth and dissolution, and so, as the molecules continue their endless dance, vibrating, spinning, colliding, they write the next chapter of creation. From their motion arises heat, chemistry, and life itself. And in that motion lies the universe's oldest story, how energy learned to remember itself. For every molecule that moves carries a faint trace of what it once was, a fragment of motion from the dawn of time, still echoing softly through the fabric of the present. And from those echoes, new harmonies will form. Harmonies of attraction, transformation, and the mysterious alchemy that binds one molecule to another in ways that go beyond science, into something like love itself. In the beginning, before the first stars kindled their light, the universe was a cloud of energy, a sea of particles drifting in the dark, unaware of one another. And yet, from that chaos, attraction arose. Not just gravity pulling masses together, but a deeper yearning, the tendency of particles to connect, to share, to bind. In that attraction was the seed of every bond, every element, every spark of chemistry that would one day lead to life. If we could give it a name beyond mathematics, we might call it love, not in the human sense, but in the cosmic one. The alchemy of quantum love is the story of how the universe learned to touch itself, to form relationships that endure through time and distance. At the atomic scale, love is written in energy. When two particles draw close, they exchange energy in subtle ways. Sometimes they repel, their charges pushing apart like opposing hearts. Other times they find balance, their electrons weaving into shared patterns, their fields overlapping until neither is separate from the other. In quantum chemistry, this joining is not metaphorical. It is literal. The wave functions of particles merge, forming a single entity described by a new equation. Two atoms that once existed independently become one molecule, not merely adjacent, but entangled in essence. Entanglement is perhaps the purest expression of this quantum love. It defies classical understanding. When two particles become entangled, their properties are no longer individual but shared, no matter how far apart they drift. Measure one and you instantly know the state of the other. It is as though they remain connected by an invisible thread that stretches across the cosmos, transcending space and time. Einstein called it spooky action at a distance, yet today we know it as one of the most profound truths in physics. The universe at its core is not made of isolated objects but of relationships, of entangled existences whispering to one another through the fabric of reality. This entanglement is not just an exotic trick of subatomic particles. It is the foundation upon which matter itself builds its complexity. In a molecule, electrons are shared across atoms existing in overlapping orbitals. Their positions and spins are correlated, meaning the behavior of one cannot be fully described without the other. This mutual dependency gives rise to stability. It is the reason molecules hold together, why bonds persist. Chemistry, in this sense, is a dance of entanglement, a choreography of particles finding harmony through shared existence. The laws that govern this dance are subtle, almost tender. Each bond is formed not by force, but by balance, by the delicate trade between energy gained and energy lost. A bond forms when the system's total energy is minimized, when togetherness becomes more restful than solitude. The universe, it seems, prefers companionship. Even in the cold emptiness of space, hydrogen atoms find one another, forming H2 molecules that drift in invisible pairs through interstellar clouds. From those clouds, under the pull of gravity, stars are born, great furnaces where atoms merge, releasing energy in luminous waves. In that merging, new elements form and the chemistry of love expands. The carbon that shapes your skin, the oxygen that fills your lungs, the iron that flows in your blood, all were born in those fiery unions. The universe's chemistry is a history of longing, particles seeking stability through connection, releasing energy in moments of fusion, scattering themselves to form new worlds. It is love written in light, yet at the human scale, this alchemy continues. The molecules in your body, the proteins, the lipids, the DNA spirals, are all products of selective attraction. Carbon bonds with oxygen, nitrogen, hydrogen, never randomly, but purposefully, governed by quantum rules that favor harmony over chaos. The molecules that make life possible are those that know how to share electrons, how to form strong yet flexible bonds. Life itself is the ultimate chemical love story, the continuation of the universe's oldest habit of joining, and this joining is not limited to atoms. Every living cell is an orchestra of interactions, molecules binding and unbinding in precise rhythms, exchanging energy, transferring information. Enzymes cradle their substrates in molecular embrace, guiding them into transformations that sustain life. DNA strands unzip and reunite, copying the code of existence with intimate precision. Within every heartbeat, millions of reactions occur, bonds breaking and forming in perfect balance. The chemistry of life is not mechanical, but is relational. Every reaction depends on timing, compatibility, and resonance. On the quantum level, the same principles that bind atoms also give rise to phenomena like photosynthesis, where light energy, absorbed by chlorophyll, is transferred through a chain of molecules with near-perfect efficiency. Recent research suggests that quantum coherence, a state in which particles maintain phase relationships across multiple pathways, allows this energy to flow as a wave, sampling all possible routes simultaneously until it finds the most efficient one. In essence, the molecules know how to cooperate. They act not as isolated entities, but as a unified network, a web of quantum relationships working toward a common goal. It is as if the molecules themselves remember the fundamental truth of the universe, that togetherness is more powerful than separation. The same principle applies to human experience. Love, empathy, and connection are not abstract feelings detached from physics. They are the macroscopic echoes of quantum principles. We are built from atoms that learn to bond, from molecules that learn to cooperate. When you hold someone's hand, the warmth you feel is the transfer of energy through countless molecular vibrations. When you look into another's eyes, the photons that leave their pupils travel into yours, creating an entanglement of light and perception. Connection is physical as much as it is emotional. Perhaps this is why love feels infinite, because at its root, it is a continuation of the universe's first act of creation. It is the same impulse that brought atoms together, that formed stars, that ignited the chemistry of life. Love is not something added to the cosmos. It is the cosmos aware of itself. The alchemy of quantum love is the transformation of energy into relationship. The realization that everything, from the smallest particle to the largest galaxy, exists not in isolation, but in communion. When we speak of the universe expanding, we often imagine things drifting apart. But maybe the truth is the opposite. Perhaps the universe is learning new ways to connect, stretching itself wider so it can love more deeply, bond across greater distances. Entanglement shows us that separation is an illusion, that once two things have met, they are never truly apart. Somewhere, at the deepest level, everything remains linked by threads of energy, invisible yet unbreakable. And as you breathe, as your molecules continue their quiet dance, remember that you are part of this same web, a single expression of quantum connection unfolding in time. The atoms within you have been entangled with stars, with oceans, with other beings. You are not merely in the universe. You are the universe, remembering how to love itself in 1,000 different ways. And from this web of connection, the next story emerges, the story of disorder that finds rhythm, of chaos that learns to sing. At first glance, the universe looks wild, a storm of chance, a dance of particles colliding in endless unpredictability. On the smallest scales, quantum motion seems erratic. Electrons appear and vanish, atoms vibrate without rhythm, molecules twist and turn with no visible plan. Yet somewhere in this apparent chaos, patterns emerge. Like waves forming from turbulent water, order arises from disorder, rhythm from noise. It is here, in the space between randomness and structure, that chemistry learns to sing. The universe, though chaotic at heart, carries a melody written in probability and shaped by time. Chaos, in its truest form, is not the absence of order. It is the presence of too much possibility. The molecules that swirl within a drop of water are not lost or aimless. They are exploring every available path. Each collision, each vibration, each flicker of quantum transition contributes to a greater harmony that only becomes visible when seen from afar. In this way, the chaos of motion becomes the music of existence. Every reaction, every change, every pulse of energy is a note in the composition. In chemistry, chaos manifests in motion too intricate to follow. When millions of molecules interact, the paths they take are impossible to predict one by one. Yet collectively, they obey laws, temperature, pressure, entropy, that describe the average behavior of the whole. Entropy, often misunderstood as disorder, is in fact the universe's measure of how widely energy can be shared. The higher the entropy, the more evenly energy is distributed, the more possibilities are explored. And yet, even as entropy rises, new structures emerge. Snowflakes forming from vapor, galaxies coalescing from dust, life blooming from carbon and water. Chaos, when viewed closely, is not destruction. It is creation in motion. At the quantum level, this creation begins in uncertainty. A particle's position and momentum cannot both be known exactly. This principle, Heisenberg's uncertainty, is not a flaw but a feature of the universe's design. It ensures that particles never fall into perfect stillness, that energy continues to flow, that possibility remains alive. The uncertainty principle allows atoms to exist, electrons to orbit, and bonds to form. Without this gentle blur, the cosmos would be frozen and silent. Instead, it hums with potential, a constant interplay of what could be and what is. The universe maintains its song by allowing uncertainty to lead. In the realm of molecules, this uncertainty becomes the foundation for life's complexity. Chemical reactions rely on randomness to bring the right atoms together, yet those same reactions follow rules so consistent that chemistry can be written like music. Each element has its own tone, its unique way of combining with others. The periodic table is not a list of materials, but a sheet of cosmic notation, a record of how matter harmonizes. Hydrogen plays the simplest melody, carbon the most versatile, oxygen the deep and resonant counterpoint. Together, their interactions compose the symphony of living matter. Even in apparent chaos, nature finds rhythm. Take the example of oscillating chemical reactions, mixtures that pulse in color, changing from blue to red to clear in repeating cycles. These reactions, like the famous Belousov-Zhabotinsky system, seem alive, though they are purely chemical. Within them, molecules react in waves, their concentrations rising and falling like breathing. Out of randomness, rhythm emerges, a spontaneous order that feels almost conscious. These reactions remind us that life itself is an extension of such processes, a continuous balancing act between chaos and stability, noise and harmony. At larger scales, the same principle holds. Stars form from clouds of chaotic gas, collapsing under gravity until nuclear fusion ignites their light. The process is turbulent, filled with eddies of dust and plasma. Yet from that turmoil, perfect spheres of radiance emerge. On Earth, the same interplay between order and disorder governs weather, ocean currents, and ecosystems. Life thrives on the edge of chaos, where structure exists, but not so rigidly that it cannot adapt. If the universe were perfectly ordered, nothing would change. If it were pure chaos, nothing would endure. It is the balance between the two that allows creation to continue. Quantum chemistry sits precisely at that balance. The unpredictable movements of electrons give rise to stable bonds. The uncertainty of energy levels creates color and magnetism. Even the way molecules fold into shapes, like proteins bending into complex structures, depends on a delicate tension between chaos and control. Each molecule explores countless configurations, guided by random motion, until it finds the one of lowest energy, the most harmonious arrangement. Life's machinery, from the smallest enzyme to the largest organism, depends on this quiet negotiation between freedom and form. And perhaps this balance speaks to something deeper, to the nature of existence itself. Within us too, there is chaos, thoughts, memories, emotions colliding like molecules in constant flux. Yet from that inner motion, meaning emerges. Our minds, like the universe, find patterns in the noise, melodies in the static. When we fall in love, when we create, when we dream, we are participating in the same universal process that shaped stars and atoms. We are making order from possibility. Chaos, then, is not the enemy of harmony. It is its source. Without turbulence, there is no growth. Without randomness, there is no discovery. Even evolution, the grand chemical experiment of life, depends on chance mutations guided by selection. Nature composes its greatest works by listening to the unpredictable, by allowing randomness to guide it toward beauty. The branching of a tree, the spirals of a shell, the flow of blood through veins, all arise from patterns born within chaos. The music of life is improvised yet astonishingly precise. It is humbling to realize that every thought we have, every movement we make depends on quantum fluctuations that could, in theory, have gone another way. And yet, out of those countless possibilities, this particular arrangement exists. This exact moment, this breath, this experience. The universe has chosen, through chaos, to sing you into being. If you listen quietly enough, perhaps you can feel it, that underlying hum, that cosmic rhythm that connects everything from the spinning of galaxies to the vibration of your cells. It is not a melody you can hum, but one you can sense, the pulse of probability. The rhythm of chance transformed into meaning, and so, the next time you gaze at the night sky and think of its vastness, remember that the same rules govern the stars and your own heartbeat. Both are born from chaos, learning to sing, from disorder, finding resonance in the quiet laws of nature. As the melody deepens, beneath this harmony lies something subtler still, a hidden geometry, a symmetry that binds the chaotic and the calm together. It is there, waiting in the spaces between patterns, shaping all that is and all that will be. Somewhere in the stillness between atoms, the universe hides its reflection. You cannot see it in the stars, nor in the spaces between them, yet everything that exists carries its pattern, a secret geometry woven into every thread of reality. To the human eye, the world may appear messy and uneven, galaxies scattered across infinity, molecules jumbled in motion, lives unfolding without order. But beneath that surface, symmetry hums like a silent heartbeat. It is the unseen artist of the cosmos, the quiet law that ensures everything has a mirror, every action a balance, every equation a twin. Symmetry is not simply beauty in the aesthetic sense. It is the language of balance, the architecture of consistency. In quantum chemistry, it defines how atoms bond, how molecules move, how energy transforms. Each atom is a structure of mirrored forces, protons balancing electrons, attraction countered by repulsion, positive harmonized with negative. Without this symmetry, matter would collapse, or perhaps never have formed at all. The stability of the universe depends upon an unspoken agreement. For every motion, there is an equal counter-motion. For every form, a reflection. At the smallest scales, symmetry governs the rules of particles themselves. The standard model of physics, the great map of the subatomic world, is built almost entirely upon it. Every fundamental particle, from electrons to quarks, follows symmetrical principles of charge, spin, and parity. These are not decorative coincidences. They are what make existence possible. If the balance between these properties shifted by even the smallest fraction, chemistry as we know it would unravel. Hydrogen might never have bonded with oxygen. Carbon might never have formed chains. Life might have remained an unlit equation in the void. And yet perfection is not the whole story. For the universe to exist, some symmetries had to break. In the earliest moments after the Big Bang, matter and antimatter should have annihilated each other completely, leaving nothing behind but energy. But a tiny asymmetry, perhaps 1 part in a billion, tipped the scales. That imperfection allowed a small surplus of matter to remain, enough to form stars, planets, and the quiet consciousness now pondering this very truth. It is a cosmic paradox. Symmetry creates order, but its breaking creates existence. If the universe had been perfectly balanced, it would have been perfectly empty. This delicate tension between balance and imperfection ripples through all of chemistry. The shapes of molecules, for instance, depend on symmetry, how atoms arrange themselves to minimize energy while maintaining equilibrium. A water molecule bends because oxygen's electrons pull unevenly on hydrogen's, creating a polar structure that gives rise to its unique properties, its cohesion, its ability to dissolve, its power to give life. That small break in symmetry is what allows raindrops to cling, rivers to flow, and cells to form. In crystals, symmetry becomes visible. Look closely at a snowflake under a microscope and you will see six-fold repetition, arms radiating outward, each an echo of the others. The same applies to minerals, metals, and even biological forms. DNA, with its graceful double helix, is an example of rotational symmetry, a spiral repeating endlessly through the code of life. Nature, it seems, cannot resist repeating itself. Every petal, every shell, every spiral galaxy follows these hidden ratios, as though the universe were practicing the same rhythm in different keys. In the laboratory, scientists use symmetry to predict the behavior of molecules, how they vibrate, how they absorb light, how they react. Quantum mechanics tells us that particles only occupy energy states compatible with the symmetries of their systems. This is why molecules can emit or absorb light in specific patterns, creating the colorful signatures we see in spectroscopy. Even beauty itself, the shimmering colors of a soap bubble or the glint of an opal, is the visible expression of symmetry interacting with light. But symmetry's reach extends far beyond aesthetics or structure. It underlies conservation laws, as in the fundamental truths that energy, momentum, and charge cannot be created or destroyed, only transformed. These laws are not imposed upon the universe. They emerge from symmetry itself. When a system remains unchanged under certain transformations, like shifting in time or space, a corresponding quantity remains conserved. This deep connection was first revealed by mathematician Emmy Noether, who showed that every symmetry gives rise to a conservation law. Because time is symmetrical, energy persists. Because space is symmetrical, momentum endures. It is one of the most elegant discoveries in all of science, the realization that the constancy of the universe is born from its hidden harmony. And yet, there is a poetic twist. While symmetry sustains the structure of existence, it is the imperfections that give it texture and life. A perfect crystal would be lifeless, unchanging. A flawless face without a symmetry would appear unreal. In quantum chemistry, slight distortions in symmetry allow molecules to react, to absorb energy, to change. Life thrives not in perfect balance, but in delicate imbalance. The curve of a petal, the tilt of a planet, the heartbeat skipping by a fraction, all are echoes of the universe's gentle rebellion against perfection. Perhaps this interplay between symmetry and its breaking is the universe's greatest art. The laws of physics set the stage with harmony. Creation adds the dissonance that gives it depth. Music, too, follows the same truth. A melody that is too symmetrical becomes predictable, lifeless. It is the variations, the subtle deviations from rhythm and tone that move the heart. In that sense, the cosmos composes its own song, symmetry as the rhythm, chaos as the improvisation, and life as the melody that rises between them. And just as the atoms within us obey symmetry, so too do our thoughts and feelings reflect it. When we seek balance in our lives, when we yearn for harmony, we are echoing the same law that shaped galaxies. Our minds find peace in symmetry because the universe itself was built upon it. Yet we also crave imperfection, surprise, growth, transformation, because without it there would be no story, no becoming. We are, in essence, the meeting point of cosmic order and cosmic rebellion. If you could step outside time and look upon the whole tapestry of existence, perhaps you would see that it is neither chaotic nor perfectly balanced, but woven in patterns of symmetry that stretch and bend, never breaking, only evolving. And so, beneath every atom's hum, every orbit's curve, every thought's flicker, symmetry waits. Invisible, eternal, composing the hidden architecture of being, but even this symmetry has limits. As we drift deeper into the heart of matter, we begin to find regions where balance fades, where existence thins, and energy becomes silence. In that quiet, the universe rests between being and nothingness. In the quiet between pulses of existence, there is something that feels like rest. Not absence, but potential. The universe, though vast and luminous, is mostly made of nothing. Between every atom lies a gulf wider than imagination, a silence more profound than any void we can name. Yet this emptiness is not truly empty. It hums faintly with possibility, a sea of unseen motion. It is here, between energy and emptiness, that reality draws its first breath. If you could shrink yourself to the scale of an electron and drift through the spaces inside matter, you would not find hard surfaces or defined boundaries. You would find clouds, waves of probability, shimmering fields of chance. At that scale, even the vacuum itself becomes alive. What we call nothing is a restless ocean of virtual particles, flickering in and out of existence, appearing and disappearing before they can be fully seen. This quantum foam, as physicists call it, is the foundation of everything. From it, energy can arise. From it, matter itself is born. The void, it turns out, is the womb of creation. The vacuum's paradox is its greatest secret. It seems empty, but it contains the energy that drives all of physics. Quantum theory tells us that even in its lowest possible state, even when every field has given up its motion, the universe cannot be truly still. Particles and antiparticles are constantly forming and annihilating, creating tiny fluctuations in energy. These fluctuations are not accidents. They are required by the uncertainty principle. If we could measure both the energy of a system and the time for which it remains stable with perfect accuracy, the laws of quantum mechanics would collapse. So the vacuum trembles always because the universe will not allow perfection. This trembling has consequences. The spontaneous flicker of virtual particles gives rise to forces we can measure, the subtle pressure known as the Casimir effect. For instance, where two uncharged plates in a vacuum are gently pushed together by the energy of the empty space between them. It is a whisper of the invisible, a reminder that nothingness is a living field. Even the expansion of the universe is shaped by this hidden energy, what cosmologists call dark energy, a mysterious pressure that drives galaxies apart. We do not know where it comes from, only that it fills every inch of the cosmos, even the darkest corners. And so we find that energy and emptiness are not opposites, but partners in an eternal dance. Energy cannot exist without a background to vibrate within, and emptiness cannot exist without the possibility of being disturbed. Together they create motion, form, and time. When a photon crosses the void, it does not travel through nothingness. It ripples through fields that stretch across the universe, electromagnetic, gravitational, quantum. Every patch of space is a web of potential, waiting to be touched. In quantum chemistry, this relationship shapes everything we know about matter. Electrons move not in perfect orbits, but in waves that blur into the vacuum, borrowing energy from it in tiny, momentary exchanges. When molecules bond, the space between them, the empty region where no atom exists, is alive with this same invisible activity. It allows electrons to tunnel, to resonate, to share presence in a way that seems impossible under classical rules. In this way, emptiness becomes a bridge, the medium through which atoms communicate, trade energy, and form the architecture of life. There is something deeply human in this realization. We spend our lives filling silence with words, thoughts, and movement, believing emptiness to be a void that must be conquered. But nature tells a gentler truth. Emptiness is not the enemy of being. It is what allows being to exist at all. The quiet between notes gives music its shape. The pause between heartbeats gives rhythm to life. The stillness between breaths sustains us. Energy without emptiness would have nowhere to move, nowhere to rest, nowhere to become. In meditation, the mind seeks that same stillness, the space between thoughts where awareness lingers without form. To touch that space is to glimpse something fundamental, that existence arises not from constant motion, but from balance. The physicist and the mystic meet here at the border between energy and emptiness, both gazing into the same abyss and seeing not void, but creation's source. It is strange, perhaps, that the same equations describing this invisible balance govern the chemistry of your body. The mitochondria that turn food into energy, the photosynthetic reactions that power plants, the gentle dance of electrons in every living cell, all depend on the movement between energy states, on the exchange between full and empty, charged and uncharged. Life is a process of borrowing and returning, of transforming potential into presence. Even death, in its quiet way, is not destruction, but dispersal. Energy returned to the field from which it once emerged. And if we extend our gaze outward to the stars and beyond, we see the same truth playing out on the grandest scales. A star shines because hydrogen atoms fuse, releasing energy that spills into space, into the cosmic emptiness. But that energy does not vanish. It travels, diffuses, cools, and one day becomes the heat that warms another world. Nothing in the universe is ever truly lost. What appears to fade is simply transformed, its motion slowed, its vibrations softened, its light spread thin across eternity. Emptiness, once again, becomes the stage upon which energy performs its endless variations. Even the night sky, dark and seemingly barren, is a canvas for this unseen exchange. Between the stars, the vacuum carries faint background radiation, the last echo of the Big Bang, a memory of when all energy and emptiness were one. That faint, ancient light whispers the same story told by every atom. From nothing, something. From silence, sound. From the void, a universe. And so, when we speak of nothing, perhaps we are misunderstanding what the universe has been trying to tell us all along. Nothingness is not the absence of meaning, but is the potential for meaning. It is the open hand that allows the gift of creation to be received. The vacuum is the most generous thing in existence because it contains everything that could ever be, waiting patiently for form. Between energy and emptiness lies a balance too delicate to name, a tension that holds galaxies aloft and gives breath to every living thing. It is a reminder that rest and motion, silence and song, death and life are not opposites, but reflections. They complete one another. If you listen long enough, the emptiness speaks, not in words, but in vibrations too subtle to hear, too gentle to disturb. It tells us that everything we see, everything we are, rises from a stillness deeper than time, and from that stillness, the next story awakens, where the equations of the cosmos begin to glow, and light becomes the language of the universe itself. Light is the first language the universe ever spoke. Before stars were born, before atoms found one another, before time began its steady march, light was already there, rippling through the newborn cosmos, carving meaning into the dark. It does not speak in words or sound, but in waves and quanta, in the subtle rhythm of energy moving through the void. To understand light is to glimpse the handwriting of creation, the way the universe writes its own story. It seems almost impossible that something so intangible, so weightless, could be the foundation of everything we see. Yet light is not only what illuminates the world, it is what defines it. Without light, there would be no color, no form, no chemistry of life. Every atom, every molecule, every cell responds to it, shaped by its presence and its absence. Light carries both information and energy. It binds the small to the vast, the past to the present. In its pulse, we find the heartbeat of existence. At its essence, Light is electromagnetic radiation, oscillating electric and magnetic fields that dance through space in perfect harmony. James Clerk Maxwell was the first to see this symmetry. In the 19th century, he wrote 4 equations that united electricity and magnetism into a single elegant framework. Those equations did not merely describe a phenomenon, they revealed the poetry of nature. They showed that light is the union of opposites: electric and magnetic, particle and wave, energy and information. In their perfect balance, the universe found its most fluent voice. But light is not only continuous, it is also discrete. When the quantum world was discovered, scientists realized that light comes in packets, photons, tiny bundles of energy that travel without mass, yet with momentum. A photon can push an atom, excite an electron, or trigger the chemistry of vision. It can cross billions of years of space and still arrive intact, carrying the message of a star long gone. Each photon is a note in the cosmic symphony, playing across time. In quantum chemistry, light is the brush that paints the canvas of matter. When photons meet atoms, they can lift electrons to higher energy levels, transitions that define the behavior of molecules, the glow of fire, the shimmer of auroras, and the color of life itself. Chlorophyll, the green pigment in plants, captures photons and turns their energy into the bonds that sustain all living things. In this way, the light that left the sun 8 minutes ago becomes food, breath, motion, thought. The same photon that warmed the surface of a leaf may, in time, fuel the synapses of a human brain. Light connects all things through transformation, and yet light does not experience time. For a photon, the moment it is born and the moment it is absorbed are the same instant. From its perspective, there is no journey, no distance, only presence. Light exists on the edge of time, where past and future fold into one. This timelessness is not mere abstraction, it is an essential truth. The universe's messages are written not in duration, but in existence, in the way light reveals what is, without waiting. When we observe the universe, we are reading its ancient letters of light. The glow from distant galaxies tells us how they formed, how they moved, how they changed. The cosmic microwave background, faint radiation that fills all of space, is the universe's oldest sentence, written when it was only 380,000 years old. Every telescope, from the simplest lens to the grandest observatory, is an instrument of translation, turning that silent radiance into understanding. Through it, the universe whispers its autobiography in photons. And still, the story deepens. In the quantum world, light is also a messenger of probability. When an electron emits or absorbs a photon, it does so according to rules of chance described by wave functions. These interactions, so random yet so precise, give rise to everything from fluorescence to photosynthesis. The way light interacts with matter defines chemical bonds, molecular shapes, and the very architecture of biology. It is as though the universe uses light to sculpt its forms, to test each variation, to refine the pattern of life. The mathematics that describe this, the equations of quantum electrodynamics, are among the most accurate in science. They tell us how photons and electrons exchange energy, how they interact across space and time. Yet beyond the symbols lies something almost spiritual, the idea that the universe is consistent with itself, that every flicker of light follows the same timeless rule. When a star burns or a firefly glows, when lightning flashes or thought arises in the human brain, it is the same equation unfolding in different keys. Light is the thread of continuity that binds all experience together. But light is not only physical, it is symbolic. Across cultures, light has always meant truth, awareness, revelation. Perhaps this is not coincidence. The moment we understand something, we say we have seen it. Illumination is both a physical act and a metaphor for understanding. When we learn how the universe works, it is not just our minds that brighten. It is the world itself made more vivid by comprehension. The chemistry of perception and the poetry of enlightenment are born of the same source. If we step back far enough, we can see that the story of existence is the story of light learning to write. From the radiation of the early cosmos to the glow of stars, from the dance of electrons in molecules to the flicker of neurons in thought, the same energy flows. It changes form, passes from photon to atom, from cell to consciousness, but it never stops writing. Every breath, every spark, every heartbeat is an echo of that original radiance. And in the end, perhaps light does more than reveal the universe. Perhaps it is the universe. Energy woven into geometry, vibration sculpted into meaning, time condensed into illumination. The cosmos may be a single, unending pulse of light, folding and unfolding upon itself, writing endless variations on the same eternal theme. You are part of that story, a constellation of atoms that learn to see, to reflect, to wonder. The light that shines from your eyes tonight was born in stars long vanished, carried through the emptiness for billions of years to find its way here. And now it lives again, translated into thought, into emotion, into awareness. The universe continues its writing through you, but even light, eternal though it seems, must one day slow and fade. As the stars burn out and the last photons stretch across an expanding cosmos, the music of radiance will soften into silence. And in that silence, the universe will once again rest at the edge of nothing, a breath away from renewal. Imagine a world without motion. No wind, no pulse, no vibration of atoms in the dark. A stillness so profound that even time seems reluctant to move forward. This is the dream of absolute zero, the coldest temperature possible, the boundary between being and not being. At this point, motion halts, energy fades into silence, and the universe whispers its faintest note. The silence at absolute zero is not just a temperature, it is a threshold, the edge of existence itself. Absolute zero in scientific language is 0 Kelvin, or 273.15 degrees Celsius. It is the point where a system's thermal energy, the restless jostling of atoms, reaches its minimum. In theory, no particle moves. Every vibration, every rotation, every flicker of heat has vanished. And yet, even here, something remains. The quantum world refuses complete stillness. It keeps a remnant of motion called zero-point energy, the faintest hum of existence that can never be erased. It is as if the universe cannot bear to be truly silent. To approach absolute zero is to approach eternity. In laboratories, scientists have cooled atoms to within billionths of a degree above it, using magnetic fields and laser light to slow their motion. As they cool, atoms begin to behave strangely. No longer individuals, but a single, shared wave of being. This state is called a Bose-Einstein condensate, and it is one of the most beautiful phenomena ever discovered. Millions of atoms merge into a single quantum state, moving in perfect harmony, as if they have remembered that they were never separate to begin with. In this frozen unity, the border between matter and wave dissolves. The discovery of Bose-Einstein condensates was not only a triumph of physics, but a revelation about nature's hidden tenderness. It showed that even at the brink of stillness, the universe creates order rather than emptiness. Instead of chaos or decay, the atoms form patterns of exquisite symmetry. They hum softly together, a collective murmur beneath the threshold of heat. To witness this in the lab is to glimpse the universe breathing in its sleep. Temperature, at its heart, is a measure of motion, of how vigorously particles move and collide. Every object, no matter how cold, vibrates. Even the coldest night on Earth, even the empty depths of interstellar space contain a faint trace of warmth. But as energy drains away, the chaos of motion slows, the collisions weaken, and the system grows quieter. Approaching absolute zero is like descending into an abyss where time loses its urgency, where entropy itself pauses to listen. In this silence, quantum rules reveal their true nature. The uncertainty principle, that particles can never have both perfect position and perfect momentum, becomes the last guardian of motion. It forbids stillness completely. Even at zero, particles quiver faintly, preserving a spark of existence. This zero-point motion is the universe's quiet heartbeat, the soundless vibration that ensures something always remains. Chemistry itself begins to fade in this realm. Reactions slow to nothing. Molecules cannot meet or change. Bonds freeze into permanence, not because they are strong, but because they can no longer move. Time, in the chemical sense, has stopped. The story of transformation and the dance of atoms that fuels stars, oceans, and minds is suspended in stillness. It is not death, but rest. The final exhale of energy before eternity takes its turn. And yet, even here, meaning persists. Scientists studying near absolute zero matter find patterns of extraordinary precision, quantum vortices spinning within condensates, waves that flow without friction, fluids that climb the walls of their containers as though defying gravity. These superfluids and superconductors are not inert. They are transcendent. They show that perfection is not lifelessness but unity. When energy falls away, coherence remains. Atoms acting not as a crowd, but as one continuous self. If we listen closely to this stillness, we may recognize something familiar. Every human life passes through its own versions of cooling and quieting. Moments where motion ceases, where thought and emotion fall into stillness. In those rare silences, something new often arises: clarity, awareness, the realization that beneath all activity there is a core that never stops being. The physics of zero mirrors the soul's own desire for rest, the longing to return to stillness without ceasing to exist. The idea of absolute zero carries a paradox that resonates far beyond science. We strive for it, but it cannot be reached. The closer we get, the more energy we must spend to slow motion further. Each fraction of a degree demands exponentially more effort, as if the universe guards its final secret behind an infinite wall of resistance. There is wisdom in that. Perfection is not meant to be attained, only approached. The journey towards stillness, not the stillness itself, holds the meaning. In the vastness of space, this principle is mirrored. The coldest regions of the cosmos, in the Boomerang Nebula for example, hover just a whisper above absolute zero. There, gases expand and cool so rapidly that even starlight cannot warm them. Yet even there, radiation from the cosmic background, the last remnant of the Big Bang, prevents complete silence. The universe's earliest memory still warms every atom, no matter how faintly. The cosmos, it seems, remembers its birth and carries that echo forever. Perhaps that is what the silence at absolute zero teaches us, that even in the deepest cold, there is memory, motion, life. Stillness is never absolute. It is simply a different rhythm. Energy does not vanish, it only hides, folded inward, waiting for the next awakening. The atoms that rest today will one day stir again, reawakened by a star, a spark, or a thought. We too are part of that cycle, energy slowing and quickening, resting and moving, remembering and forgetting. Our bodies cool when we sleep, our hearts slow when we dream, and in that nightly silence, our minds reset. In those small hours, we approach our own version of absolute zero. Not the end, but the beginning of restoration as the last heat drains from a dying star. As its light fades into the darkness, the universe itself moves closer to this perfect stillness. But it is not the silence of despair. It is the silence of completion. The energy that once burned in stars will spread evenly through space, filling the cosmos with a calm so total it becomes infinite. This is not the death of creation, but its deep rest, the universe dreaming before the next dawn. And somewhere in that dream, between stillness and spark, something begins to stir once more. The atoms long asleep begin to remember. Their memories hum faintly, whispering of stars and warmth, of bonds and becoming. The silence begins to lift. For even at the edge of cold eternity, the universe holds one last secret. Atoms never forget the heat from which they came. And so from that deep quiet, a new light begins to shimmer, a reminder that matter itself still remembers its birthplace among the stars. There is a moment, somewhere between darkness and dawn, when even the coldest atom seems to remember the warmth of its beginning. If one could listen closely enough, past the hum of galaxies, past the silence between particles, you might hear the softest dream. An atom imagining itself as a star. For everything that burns in the heavens was once the smallest whisper of matter, waiting for the chance to ignite. Atoms, by their nature, are dreamers. Hydrogen, the simplest of them all, waits on proton, one electron, holds within it the potential for suns. Alone, it is fragile, light enough to escape the grasp of gravity. Yet when countless billions of them come together, gravity begins its ancient work. It pulls, it gathers, it whispers them closer. Pressure builds, motion quickens. Deep within this invisible gathering, atoms begin to fuse, their dreams of light taking form. In that sacred moment, a star is born, and the universe breathes out another note in its endless song. The story of stellar birth is written in quantum chemistry. Inside every star, hydrogen atoms collide with such ferocity that their quantum boundaries blur. Protons merge through a process known as nuclear fusion, transforming into helium and releasing radiant energy. What seems like chaos is, in truth, a perfect choreography of quantum forces, a balance between attraction and repulsion, probability and inevitability. The energy that warms a morning sky, that glows in the eyes of every living creature, began as a quantum event inside the hearts of dreaming atoms. Fusion, at its essence, is the great act of becoming. Two atoms, once separate, merge into one, releasing energy not through destruction, but through unity. It is the alchemy of creation, the same principle that governs every bond, every transformation. In chemistry, this is echoed in the merging of electrons, in the sharing of spaces between atoms to form molecules. Whether in the quiet warmth of water or the furious heat of a sun, the language is the same. Connection gives birth to light. The dream of atoms does not end in the heart of stars. It continues in the ashes of their death. When a star has burned enough hydrogen, it begins to fuse heavier elements: carbon, oxygen, silicon, iron. Each new element is a word in the vocabulary of existence. When the star finally collapses, it scatters those words into the darkness, seeding galaxies with the raw materials for worlds and life. Every breath of air, every leaf, every heartbeat on Earth is built from stardust, atoms once cradled in the furnace of ancient suns. Quantum chemistry tells us that even in their simplest form, atoms are restless storytellers. Their electrons shift, their energies change, their bonds form and break, all guided by unseen probabilities. But perhaps these probabilities are more than randomness. Perhaps they are the faint outline of desire, the drive of the universe to know itself, to burn, to feel, to become aware. For when atoms organize themselves into molecules and molecules into cells and cells into consciousness, the dream of the atom finally speaks. It calls itself life. To think that every thought, every memory, every whispered word of love is powered by ancient atomic dreams, the same energy that once illuminated the void, is to feel both humbled and infinite. The photons that leave a star's surface can travel for millions of years before finding a human eye. And when they do, they awaken something familiar, as if the stardust in our blood remembers the light it once belonged to. There is poetry in the precision of this science. When electrons leap between energy levels, they emit or absorb light in exact wavelengths. These lines of color, the spectral fingerprints of elements, are how astronomers know what stars are made of. Each element sings its own song, and when combined, they create the great symphony of the cosmos. To gaze at a star is to listen to the chorus of atoms, each note a whisper from across eternity. In the cold night sky, stars appear as still points of light, yet each one is a storm, a quantum cauldron of fusion, gravity, and radiant release. The atoms within them collide billions of times per second, and yet the overall effect is calm, steady brilliance. The balance between chaos and harmony mirrors life itself. Beneath our composed surfaces, countless reactions unfold within our cells, keeping us warm, alive, dreaming. The same physics that holds a star together keeps a human heart beating. When we look at the stars, we are not merely seeing distant suns. We are watching the story of chemistry taken to its most divine form. Energy made visible. Each photon that reaches our eyes is a messenger from a reaction that began before our world existed. That light has traveled across time to remind us, creation never truly ends. Even when a star dies, its elements scatter, its light fades, but its influence persists. Soil in the air, in the laughter of living beings. Perhaps this is what it means for atoms to dream of stars. Not that they wish to burn, but that they wish to belong to something larger, to shine as part of a greater pattern. Within every human, every leaf, every drop of water, that dream continues. The hydrogen in our veins is older than galaxies. The carbon in our bones was forged in the heart of a dying star. When we breathe, when we think, when we love, we give the universe back its memory. There is a tenderness in knowing that the light of a distant star and the warmth of a human touch are born of the same process. The physics that makes suns shine also makes hearts beat. The same quantum dance that drives the fusion of atoms drives the chemistry of emotion. When you feel awe beneath the night sky, it is not simply beauty you are sensing, it is recognition, a quiet homecoming of matter remembering itself. And so when you gaze upward and see the faint shimmer of starlight, remember that the atoms in your eyes were once the fire in another sky. You are the universe looking back at itself. The dream fulfilled, the light returned to its source. The boundary between the self and the cosmos fades, and in that gentle blur, everything feels whole. The stars burn because atoms dream, and atoms dream because the universe does not wish to sleep forever. It longs to awaken in infinite form, to feel, to think, to love, to shine. From the silence of absolute zero to the blaze of supernovae, this is the rhythm of all existence, stillness to motion, darkness to light, dream to awakening. The atoms that once slept in the heart of stars now live in you, continuing their luminous story. And when your gaze meets the night sky, you are not a spectator. You are the continuation of that dream, the universe remembering how to shine. Somewhere in the silence between seconds, the universe exhales. The light of distant stars drifts across billions of years, whispering through the fabric of time, touching dust, water, and thought. It does not hurry. It does not end. In that endless motion, that quiet continuity of existence, lies the chemistry of forever. It is not an eternity of stillness but of transformation, atoms changing shape, energy passing from one form to another, memory folding through matter. Forever, in truth, is not a destination. It is a process. The story of the cosmos began with a spark, smaller than imagination, the Big Bang, a release of energy so vast it created everything we know. In those first moments, there was only heat, light, and expansion. Then came the cooling, and from cooling, structure. Hydrogen and helium were the firstborn elements, drifting freely through space, guided only by gravity's invisible hand. Over billions of years, these simple atoms learned to gather, to fuse, to ignite. Stars formed, burned and died, each one scattering new elements into the dark. From that cycle of death and rebirth, every planet, every mountain, every living cell emerged. This is the chemistry of forever. A cycle that neither begins nor ends, only changes its name. Every breath you take is part of this unbroken lineage. The oxygen that fills your lungs once drifted through the veins of ancient forests. The carbon in your blood was forged in the furnace of a long-dead star. Even the water you drink, each molecule of hydrogen and oxygen, has existed for billions of years, passing from cloud to river to creature to cloud again. Nothing is truly lost. It only changes its pattern. Entropy ensures that order becomes chaos, but chemistry ensures that chaos becomes life again. In quantum chemistry, this eternal motion takes form through the exchange of energy, the smallest acts of giving and receiving. When a bond forms between atoms, energy is released. When a bond breaks, energy is absorbed. These tiny exchanges multiplied across the fabric of existence sustain the balance of everything. From the formation of galaxies to the beating of a human heart, the same principle echoes. The universe survives through transformation. Nothing holds forever, yet nothing disappears. On the grandest scale, even stars are part of this law. A sun may burn for billions of years, but its fuel will one day run dry. It collapses, flares, or fades, returning its elements to space. In time, new stars form from the remnants, carrying within them the ashes of their ancestors. In that way, even destruction becomes a kind of creation, an inheritance passed from one generation of light to the next. The universe recycles itself endlessly, weaving old energy into new expression. Perhaps that is the secret of immortality. Not to remain unchanged, but to remain in motion. Every living thing, from the smallest microbe to the largest galaxy, participates in this cycle. When life ends, its atoms return to the soil, to the wind, to the ocean, to the sky. They are never truly gone. The carbon in a fallen leaf may one day rest in the heart of a diamond or the core of a new planet. The calcium from a bone may float as dust through space before becoming part of another living creature. The chemistry of forever does not promise permanence. It promises return. Even our thoughts, fleeting and intangible, are shaped by this same rhythm. The signals that move through our brains are electrical, chemical, quantum. Tiny interactions of particles exchanging energy and information. When we dream, when we remember, when we love, we are participating in the same dance that once forged the stars. Consciousness itself may be the universe's most intricate chemical reaction, the place where matter awakens to its own existence. If we look deeper still, down to the quantum level, we find that forever is written into the uncertainty of things. Particles appear and vanish in the vacuum of space, their lifespans measured in fractions of seconds. Yet they never truly die. They leave ripples in the quantum field, echoes that shape the particles yet to come. Even in emptiness, there is a kind of continuity, the endless hum of potential. Space is never silent. It is alive with possibility. The chemistry of forever is not limited to atoms or stars. It is also emotional, human. The bonds we form between parent and child, friend and lover, teacher and student, follow the same pattern of exchange. We give energy, we receive it, we transform through it. Every act of kindness, every word of understanding, every spark of curiosity leaves a trace that outlives its moment. Just as stars seed galaxies with their ashes, our actions seed the minds and hearts of others. Perhaps this is what the universe seeks, not to exist forever as matter, but to remember itself through connection, to know itself through awareness, to dream itself into meaning. The atoms that once slept in darkness have learned to think, to feel, to question. They have built telescopes and symphonies, cities and stories. They have begun to wonder about their own beginnings. And in that wonder, the cosmos finds its reflection. When you look at your own hand, you are looking at an ancient map. The elements that form your skin have journeyed across time, from the explosions of dying stars to the cooling of newborn worlds, to the rise of oceans and life. You are not a separate being moving through the universe. You are the universe arranging itself into awareness. Every heartbeat is a ripple in eternity. Every thought is an echo of creation remembering its purpose. The chemistry of forever is not something that will happen after time ends. It is happening now in every molecule of your being. The blood that moves through your veins carries iron from supernovae. The water in your eyes once passed through clouds above forgotten continents. The breath you exhale will nourish trees that will one day breathe you back in. You are both the observer and the observed, the star and the dust, the silence and the song. When all stars have burned out, when galaxies fade and space grows cold, even then the memory of light will linger. The energy released in every reaction, every heartbeat, every thought will continue to ripple through the void. Quantum fields will still hum softly, holding within them the blueprint of all that ever was. The universe will rest, but not vanish. For in rest, there is the possibility of return. A new beginning waiting to bloom from the ashes of stillness. And so forever is not a promise of endless life, but of endless change. It is the rhythm that binds all things, atoms to stars, stars to life, life to memory. The chemistry of forever reminds us that endings are illusions. They are simply new beginnings wearing different names. We are made of the same matter that once lit the heavens, and one day that same matter will light the heavens again. Between those moments we live, we dream, we learn to love the brief brilliance of being. And in doing so, we fulfill the oldest wish of the cosmos, to know itself endlessly. For even as time dissolves and every atom drifts into silence, the story continues, soft, eternal, and beautifully unfinished. This is the chemistry of forever.